This next series is a pretty easy series to work with, and we end up using it quite a bit in subsequent tests that we do. So this is a good one to really get to know, but it's not a very difficult one. So we've got this p series, and it's in the form of 1 over n to the p, where p is a constant, a positive constant. And the nice thing about it is there's just two simple rules to remember. If the p is greater than 1, the series will converge. Okay, so that's if the exponent is greater than 1, it'll converge. And if p is between 0 and 1, including 1, then it will diverge. Okay, in this last case, where it equals 1, is a harmonic series. And the harmonic series diverges, and we use this in, like I said, in these upcoming tests, so you just need to really have that internalized. This harmonic series of 1 over n to the p, when p is 1, it always diverges. And it's an interesting side note. It's harmonic, it's related to music, and when you have lengths of strings that have the same material and the same diameter and all that, and if their lengths are in, if they form a harmonic series, then when you pluck them, then the tones will be harmonic. So there's a lot related to music with this. It's kind of a cool thing. So anyway, let's go ahead and look at example 1. We're going to use the integral test to show that the harmonic series diverges. And you could use the integral test for any of these cases, but the nice thing about it is with these rules, it keeps us from having to do the integral test. So, but let's go ahead and do it on the harmonic series just to see. So we would have the harmonic series, let S be the sum from n equals 1 to infinity of 1 over n, and I'm just going to write it up there to the 1, but of course it would just be 1 over n. Okay, so we're going to let f of x be 1 over x, which is, for x is greater than 1, decreasing, positive, and continuous, so the integral test does apply. So then we're going to do the integral from 1 to infinity of 1 over x dx, and we're going to do that by taking the limit as b goes to infinity of 1 over b, 1 to b of 1 over x dx. And that's going to be the limit as b goes to infinity of the ln of x from 1 to b, which is going to be the ln of b minus the ln of 1, as b goes to infinity. We need to write that in there. And since b is going to infinity and there's no way for us to simplify that right there, then this is going to go to infinity. And so therefore S diverges by by the integral test. Okay, real straightforward. There's just nothing tricky about this at all. Okay. All right, so let's determine, we'll use this p-series test to determine if the following series converge or diverge. So we have, in our first example, we've got n to the 2/3. So p is 2/3, which is less than 1. And if we go back up here and look, when p is greater than 1, the series converges, and when p is less than 1, it diverges. So S equals, S diverges by the p-series test. And the reason why, I didn't really explain, the reason why it works this way is it's all about, how fast these terms are getting smaller or decreasing, and that's what is making this diverge or converge. So when we look at these, when p is greater than 1, then we're going to have 1 over 1 to the 5th plus 1 over 2 to the 5th plus 1 over 3 to the 5th. Those denominators are going to get big really fast, and so this series, the term values are going to decrease very, very quickly, and that would allow the area under the curve to get small enough that it will, converge. And but with P being between 0 and 1, then it's a really slow growth, or not growth, I'm sorry, really slow decrease. And so therefore, the terms don't get small enough, fast enough, that the series will just continue to get bigger and bigger and bigger instead of going to one number. So that's what's happening. And this should, be somewhat familiar to you after doing our, things like the geometric series, that sort of thing. So, okay, so let's look at B. In B, this is a P series, and P is 3/2, which is greater than 1. So then, if I call this S, and I use S because it's sum, you don't have to use S. S diverges by P series. Okay, all right, let me pick a different color. These colors are boring. All right, so now we've got the integral, I'm sorry, not the integral, the sum of 3n to the negative 2. Now this doesn't look like a P-series test when you first look at it, but we could rewrite this as the sum of n from 1 to infinity of 3 over n squared. And suddenly now it does take on the form of a P-series where P is 2, which is greater than 1. And so, oh, you know what? I just caught my mistake. Oh my goodness gracious. Y'all were probably having a fit. This converges. My goodness. Okay, so let's go back to this one. All right, so P equals 2, which is greater than 1. So therefore, let's call it something different. We'll call it M. M converges by P series. All right, so you get the gist. You know what's going on. I didn't leave myself enough room with these problems. Okay, so we've looked at this one before. We've seen it. It looks familiar. 1 over n to the square root of n. And we can rewrite that as the series n equals 1 to infinity of 1 over, and that's n to the 1 and n to the 1/2, which is n to the 3/2, which we already saw, converges, even though I said it diverged to begin with. Silly me. I'll put an extra one on there. All right, and then I'm going to take this one and bring it down because I don't have any more room. So the series is n equals 1 to infinity of n over the square root of n. And that is, I shouldn't write equals there, that is n to the 1 over n to the 1/2. We subtract, so that's going to equal n to the 1/2. Let's write it so you can see it. N to the 1/2. And if you wrote it as a P-series, that would be 1 over n to the negative 1/2. So P would be negative 1/2, which is less than 1. Now, if you remember up here, we talked about that the constant needed to be from 0 to 1, and this is less than that. But if you go back and if you think about it and look right there, that's obviously going to diverge. So we can still conclude that diverges. But that that would be one that I would end up using the nth term test on or something like that. So anyway, that's all there is to it. Easy peasy. So work on the problems and let me know what questions you have. Have a good one.